Inside your head is a sprawling, complex system of 86 billion biological neurons. They fire in synergy, transmitting coded information electrochemically to process everything we perceive. This dense web makes human learning, reasoning, and creativity possible. Modern artificial intelligence translates this biological structure into mathematics, turning the living neuron into a mathematical node that calculates inputs. By organizing these nodes into dense layers, we escaped the limits of rigid algorithms and explicitly programming step-by-step instructions. Instead, these systems learn by induction. By observing billions of examples and studying them repeatedly, they build their own internal models. They identify patterns entirely on their own. You might picture a modern language model searching a hidden database, but no literal sentences or images are stored inside. Instead, it absorbs the abstract relationships across billions of text and image examples, weaving them into a dense web of knowledge. Reproducing the human capacity for pattern recognition was a significant technical milestone, yet those iterations from 2022 remained entirely passive. You provide a prompt, the AI generates an answer based on its learned patterns, and then it stops. It waits indefinitely for your next command. This reactive cycle prevents a system from tackling long, complex projects that require multiple steps. Solving larger problems requires a mind capable of taking independent action. To understand how we move past that reactive cycle, we can look at how humans think. The psychologist Daniel Kahneman divided our thinking into two distinct systems. System 1 is fast, automatic, and unconscious. It is the snap judgment you make in a fraction of a second. Early language models operated primarily like this, simply predicting the next logical word without pausing to reflect. System 2 is deliberate. It is what you use when you stop, focus, and map out a methodical plan to solve a difficult math equation or navigate an unfamiliar city. Modern AI models are now crossing into System 2 thinking. Instead of blurting out the first word that comes to mind, they pause. They generate internal chains of thought, testing out different routes, recognizing when they hit a dead end, and backing up to try a new path. Giving an artificial mind the space to deliberate and weigh alternatives provides the foundational requirement for independent operation in the real world. Thinking slowly and carefully accomplishes very little if you lack the hands to do the work. A plan requires execution. This brings us to the concept of AI agents. An agent is an AI system equipped with the autonomy to carry out long cognitive tasks over extended periods without constant human supervision. Instead of waiting in a chat window, an agent can reach out and use digital tools. It can open a web browser to research a topic, query an external database, or execute commands directly on a computer's operating system. It operates in a continuous loop. The agent takes a step, reads the results from its environment, adjusts its plan if it hits a roadblock, and moves to the next step. It iterates until the goal is met. Combining deep reasoning with tool use turns the AI into an active digital worker, capable of navigating a computer and executing tasks just as a human does. Because agents run in a continuous loop, they do not have to wait for us to wake them up. They can operate proactively. An agent can sit in background and monitor a live data stream, like server traffic or a crowded email inbox, identifying subtle anomalies and taking action without a human ever pressing start. When that agent encounters a massive, multi-layered problem, it does not have to solve everything alone. It can dynamically create its own specialized subagents. The primary agent acts as a project manager, dividing the objective into smaller pieces. One subagent might gather data, while another writes code to process it. They complete their distinct tasks and report back to the coordinator. The system operates as a manager, capable of spawning an entire digital workforce precisely when it needs one. We can scale this concept of specialized subagents even further. Imagine thousands of distinct agents, each with their own specialized abilities, populating the digital network. In this environment, agents communicate and coordinate. They share data and specialized labor, working together to achieve monumental cross-disciplinary goals in engineering or science that no single AI and few individual humans could handle alone. This creates a macro structure of distributed intelligence, Just as billions of biological neurons work in parallel to create a human mind, hundreds of networked agents work together to simulate the same collective power we see in human scientific collaboration. AI has moved beyond software that simply waits for instructions. We are entering a partnership with a proactive intelligence, one that is increasingly capable of managing complex objectives alongside us.